What is arrays? Arrays and pointer shares a lot of common things, right? But they are not same. Let us see where they differ. First thing, the arrays are collection of variables of same data type arranged in sequence. In Python, we study list, right? We can equate our list of Python to arrays. The only difference is there you can have a mixture of different object type. Here, all content of array should have the same data type. Only then we can increment. We can move, use the index to navigate. That is fixed in C, right? Okay, so the syntax to declare array in C is data type of your array, the name of array, and then the size of your array. You have to give your size within a square bracket. Right. Array elements are accessed using index and subscripts. So subscripts means the square bracket. Within that we can put the index from which index we want to fetch the data. The index start from 0. It is also same like list. Array can be multidimensional. You can have multidimensional array as well. These multidimensional arrays are used in C to store strings, those sort of things, because there is no keyword for string in C program. Every string is a collection of character, right? When you want to show some sort of menus or something like that, in those cases we have to go for multi-dimensional character array. Maybe probably two-dimensional character array we have to go. Right. Array and pointer as common ground but not same. So here they have given some sort of examples to understand that how they are not same. So they have a myPTR, probably it is an address. With that they are adding X as offset. That means from the current address which is there in the myInPTR, right? From that address they add X as an offset right now. So in that location, what they are doing it, they as they put star outside from the current memory location that we have in the myInPTR +4, you change the for that memory location you assign from the myInt array. They have another array called myInt array. MyInt array, from the X index you take that particular element and assign it to this one. So this statement is little bit complex. Let me write a program so that we will understand what they are really trying to do. First thing is we need a pointer variable which is myInPTR, and then we also need an array which is myInt array. Let me declare both. Right. Let us declare them as initially a null pointer. My array, myInt array. I have some 5 elements in this array. So let me assign those elements. Right, 1, 2, let us make it simple so that while we are doing those operations, it will be easy for us to understand. So after that, what they are doing from the memory location pointed by myPTR plus X. Do we know? Actually, by default, now it is not pointing any memory location. Right. Which one? My int PTR is not pointing any memory location. It is null now. So to give some sort of recognition, what I do, I just create another array. I call this as dummy array, which is having again some 10 elements. Right. So it is like 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Correct now? Right. So as per these expressions, what they are doing means, let me copy and paste this expression here, and then we will discuss what they are really doing here. What is okay? I have to point it. So my PTR, my int PTR is equivalent to dummy. Why I didn't put address dummy? When we use a p pointer, we use address k, no? Why we are not doing it here?
Because the pointer name contains the address. Because pointer name
See,
contains.
one sec. Here also, here actually we have to declare when the other way around to do this one is I can do like this as well. After I declare it, sorry. So initially you declare it. After that, I can say like this: PTR is equivalent to address of k. Even that is correct only. So as we are doing declaration and assignment at the same time, we are doing it here. So if that is the case, right? If that is the case, here I just used address of k, but here I am not using address of dummy. Why? That is my question. Because dummy is an array.
Yes, sir.
Actually, the dummy, when we call dummy, we are actually coming the address of dummy. That's why we don't put address. If it is variable, we have to put address. Right. So I did that. What will happen here? They will take the dummy address. With that, we also have an x. No, let me define an x here. Int x equivalent to 3. Right. So whatever the address, the starting address, from there plus 3. For example, the starting address is x, means x plus 3. So in starting address we have 6, right? From here if they add 3, so this is a 0 means, so this 9 will be replaced in dummy. 9 will be replaced with starting address plus 3. 3. Do you agree? 9 will become 3. No, actually 8 will become 3. The 8 in dummy will become 3 if I execute this statement. Do you agree? No. 8 will be plus 3 only, no. So I have plus 3, right? So 8 will be replaced by 4. Agree?
Yes, sir.
8 will be replaced by 4. Let us check. After that, we have to print. In order to check that, we have to print dummy. Only then we will know that. So what we will do, print, we use a for loop here.
Yes. Yes, sir.
Rider equal to, yes, because
Yes, sir. 8 will be, I think, replaced by 3.
no, 8 will be replaced by 4 because 0, 1, 2, 3. This is index, no. If I put 3 here, 0, 1, 2, 3. 3 is 4
Okay, okay. Yes.
right now.
Yes.
So rider less than we have 5 elements, no, 5, no, 10 elements. 10 elements. Rider plus plus. Here printf %d, comma, right. We print dummy of rider. Make sense? Yeah. One sec, somebody is knocking my house door. So from here, yes. So that is what we told, no. So did we compile it? Actually, we are not printing any. Oh, we printing. Okay, this is another array and pointer, right? File is different. What is ARR? ARR point.c. GCC ARR point.c -o ARR point.exe. So they say dummy. Note each unindexed I will put it only once. Each function appears in int dummy. Here dummy undeclared first used in this function. From my view, it is somewhat okay. Thank you. Missing terminating character. I saved it now. I saved that. Why it is complaining? Okay, maybe I didn't compile it again. Compile it station itself. It's throw error. ARR point.exe missing terminator closing character. stdio.h. Okay, maybe here it starts right here. Function main error expected before int. Maybe I am missing some sort of termination character. Yes. Right. Right. So we are getting 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 without any change, right? we get 6 to 15. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So the dummy is undisturbed. Why? My int ptr plus x, which is the starting address, plus x, we gave 3, is it okay? We are comparing. It is not assignment. We just compare. Okay. 6, 7, 8. Actually, they didn't replace 8 by 4, but 9 by 4. Why they are replacing 9 by 4? 9 is replaced by 4 right now. So we have 4 here. This is correct. The index that with 0, 1, 2, 3 is correct. But while assigning the same 3, let us say we have some address 200 for 6, 201, 202, 203. Correct. The 9 is replaced by 4.
Yes, sir.
So this statement, actually what we are doing, we take the address of dummy. With that, we add an index 3. In that memory location, whatever the content that we have, we replace it with myInt array content. So this works. This is one sort of things that we have. After that, they do it in a different way. MyInt ptr of x. Actually, MyInt I did know. So I am doing the same thing in a different way. This is one way of doing things, right? Using star and then pointer plus offset. As I already pointing this dummy array, I can navigate to that array using myInt ptr. You can ask me a question. This is a pointer, no? You have to use only star to access element. So the star in the front and square bracket at the end, both are same. So to navigate to that particular location, we just say myInt ptr of 3, my array of x. This will produce the same result. So what I do, what we can do is we can reverse what we did before. We will do myInt ptr is pointing what? Dummy right now. So dummy, and then otherwise let me comment this. So I copy paste this to here. And we remove. So I use in place of pointer arithmetic, I use the array method. So I just use that pointer name and then square bracket and the index value. So this should also produce the same result. Let us see whether it is producing that. Right. Same result it produces. But what they are saying is Okay, this can be true, but this may not be true. So my ptr plus x equal to my array. We did like here in pointer arithmetic, we just take an address and then we add an offset. No, like that, can I do it in array? We use the property of array in pointer to do the things, right? To do the usually how you used to access the element of array name within the square bracket, we'll put the index. So that method is used. Can I use the pointer method in array? That is not possible. That is what they are saying. So for that, what I do, we can copy paste this third expression. My star ptr plus x. This is okay. Dummy is pointed by my in ptr, so that from there 3 index they are going. My int array plus x, as we did here. Can we do like that? Answer is you cannot do. You cannot perform that. If you run it, it will throw some error. Let's see. It's throw error. Maybe we have to use this assignment operator. So even we can try for assignment makes integer from pointer without a casting. Okay. So I can do like this as well. I can try this as well, because array name is nothing but an address plus x. It is doing, but it cannot be same always, because if we increment my int ptr to next level, that means if we increment the my int ptr and then when we try to use my int ptr plus x, my int array of x, that won't work, because array always point a fixed address. That means array beginning is always pointing a array name is always pointing a starting memory location. That's all. Can we modify the starting memory location of array by incrementing or something like that? We cannot. But in pointer we can do that. That is what the problem that we faced in the previous example. We simply incremented the pointer variable. As we incremented the pointer variable, entire arithmetic that we did, pointer arithmetic went wrong. So we some of the things that we have in pointer, we can try with an array option, but all options in array are not applicable to pointer. That we have to be clear while we work with arrays and pointer. That is what they are trying to say.